All right, so this section, we're going to do a little short version of the section. The section talks about graphing tangent, cotangent, cosecant, and secant. We're only going to talk about the graph of tangent. All right, my cats are okay. They're doing something weird over there, though. And so we're just going to start by introducing this graph by reminding all of you about something we like to call the unit circle. You may have heard of it before. I'm going to do my best drawing of a circle, which isn't very good, but you know, we're pretending a lot in this class. The thing about the unit circle is it has a radius of 1. It's centered at the origin. And then we can think about a point, x comma y, on the unit circle. And so since the hypotenuse, oh wow, that is a bad y. Since the hypotenuse is 1 of that triangle, well, we can say that, okay, the sine of that angle, let's call that angle theta. The sine of theta is the opposite divided by the hypotenuse, which is just y. The cosine of that angle is just the x coordinate. And the tangent of that angle is sine divided by cosine. And this is what we're going to look at today, tangent. So what is the value of tangent for different values of theta? And the answer is, we will see. So let's start with this. Let's start with theta is equal to 0. Well, tangent is y divided by x. Well, the y coordinate is 0 here. So we know that tangent has to start at 0 because the y coordinate here, right, this is the point, 1 comma 0, so 0 divided by 1 is 0. So tangent's also going to start at 0, kind of like sine. And then notice what's happening. We get up here. Maybe this is pi over 4 radians. This is when the x and the y coordinate are the same. Tangent's going to be 1 here. And tangent, indeed, keeps getting bigger and bigger. Here, y is very big, and x is very small. What happens when you have a big number divided by a really small number, like 10 divided by 0.01? This gets really, really big. And as we get even closer, right, that might be like, you know, maybe that's going to be 0.99 divided by 0.00001 or something like this, you know. And as we get closer and closer to this point right here, well, not right there, but on the unit circle, right, x is getting closer and closer to 0, so we're dividing by a number that's really close to 0. We're going to have an asymptote here. Tangent gets really, really big because it's undefined. Tangent's not defined right there. Okay, so tangent's going to have an asymptote, kind of like 1 over x, if you remember that graph. And so let's kind of look at this. This is kind of where tangent comes from. If we pull up Desmos and then go, hey, I want to see what tangent looks like. So you go click over here, you type in y equals tan x, and whoa. It is also periodic. Tangent also repeats. And yeah, it shoots off to infinity. Zoom. Let's change things in terms of pi. Let's say, let's look up to 2 pi maybe. Maybe down to maybe negative 2 pi. Let's divide this into maybe pi over 4s. Now look what's happening. So starts at 0, just like we said. At pi over 4, it's 1, right? That's 45 degrees. The tangent of 45 degrees is 1, pi over 4. And then it shoots off to infinity. It actually gets as big as we want it to get. Look how big it gets. Look how big it gets. All right, that's hurting my eyes. That was a mistake. And then it also goes down here. And when I say asymptotes, we haven't talked too much about those. That just means if we look at the line x equals pi over 2, tangent gets really close to this line, but it never touches it. I don't care how far up we go. They get really, really close, but they never actually intersect. That's what we mean by asymptote. And there's a bunch of asymptotes here, right? There's also an asymptote at negative pi over 2, right? There's also an asymptote right here. Can make it look the same. There's also an asymptote at 3 pi over 2. I think that's where that is. Yep. You know, there's infinitely many asymptotes, right? Because as we kind of scroll, this graph is periodic. It repeats. How often does it repeat? Well, the center of this one is when x is equal to 0. The center of this one is when x is equal to pi. The center, if you will, of this one is negative pi. Okay, this is pi periodic. Sine and cosine had a period of 2 pi. Tangent just has a period of 1 pi. Okay, so since tangents has asymptotes and tangent's periodic, the asymptotes are also going to repeat. Okay, so let's kind of summarize all of this and use this to do an example. So if we look at the function y, let's not use blue. If we look at the function y is equal to a times the tangent of bx, we're going to have a couple results that are very familiar with 8.1, with the interpretation for what these a and b values represent for sine and cosine. All right, so we're going to have a stretching factor a, technically the absolute value of a. Be very careful. This is not called amplitude anymore. It's very closely related, but it's not amplitude. Amplitude is only for sinusoidal shapes. This is the stretching factor. Amplitude and stretching factor are very similar, but we don't call it amplitude, okay? But it does the same thing. The period. So for sine, don't write this down yet. I'm going to write down the wrong answer. This is the period for sine. But what's the difference? Tangent no longer has a period of 2 pi like sine and cosine do. Tangent has a period of 1 pi. So to find our period formula, it's just going to be 1 pi divided by the absolute value of b. Okay? Because b is just a compression or a stretching horizontally. B just means how much faster do we go? So if b is 2, we go twice as fast. So the period used to be pi, and then we're going twice as fast, so now it's pi over 2 in that little example. Okay? There's the domain, there's vertical asymptotes. There are formulas for those, but in general, right? The domain is just going to be everything except where these asymptotes are, which is at pi over 2 plus or minus multiples of the period. Okay, it's periodic, so all you have to do is find one asymptote and then add the period as many times as you want to get other ones. So we're usually going to write that, the asymptotes. They're vertical lines, so they're of the form x equals. And the first one is going to be at half of the period. Okay? So the first one is going to be at half of the period, and the period is pi over the absolute value of b. So what's half of that period? Right there. So all you have to do is find the first one, and then add the period. And in fact, not just adding the period once, but adding the period as many times as we want, where k is an integer. So k is any integer. Let's write it in this notation. Introduce some new notation for you. Okay, this is the element symbol. Kind of looks like a curvy E. And then we'll write a bold Z like this. And what this means is k is any integer. So again, let's recap because this looks kind of spooky. This is just the location of any asymptote. Of any asymptote. And this right here is just, oops, the period. So that's what these asymptotes are. This is the formula that we can use for things of this form. A couple other things about tangents graph. And the domain is just going to be everything except all of these. Right, domain. Whoa, what is that word? Domain is everything except the asymptotes. Range. What is the range? Range is all the y values. Well, look at this graph. It goes off to positive infinity, goes off to negative infinity, hits everything in between. The range is all real numbers. All right, and the last thing I want to talk about is that tangent is an odd function. Remember, an odd function just means it's symmetric about the origin. Okay? Any point you pick, if you reflect it, bounce it across this line right here, you're still on the graph. Bounce it across that origin, you're still on the graph. So it is odd. Couple of ways of writing it. One of the ways that's very useful for us is this is true. All right. A reflection about the x-axis is the same as a reflection across the y-axis. I flipped that. Reflection across the y-axis is the same as a reflection across the x-axis. Okay? So these are all the things that we can use for tangent graphs in this form. Let's do an example. Sketch a graph of two periods of the function y equals 0.5 or 1/2 times the tangent of pi over 2x. So we are going to graph it with Desmos and then copy our graph here. Let's get some good stuff here. All right, so let's tab out to Desmos. Let's hide these for now. Let's look at 0.5 times the tangent of, and again, you can just type pi to turn it into pi divided by 2. Press tab to get out of the fraction. Type an x, like so. So when we copy these down, when we graph something on Desmos and then copy it down to our paper, we need to understand what we're looking at, okay, in order to make sure that this graph is readable. So first off, let's look at the period. When does this function start repeating? Notice it repeats every 2. The period has nothing to do with pi. So let's go over here, click that wrench icon. Here, let me show you it. Click this wrench icon and change the step. We don't want to count by pi's anymore because this function doesn't have a period that has to do with pi. Let's count by 1s. All right, maybe we'll look at, we need 2 periods of this graph. Oh, well, this actually does give us 2 periods, but then they're not really connected. So let's maybe look from -1 to +3. Now we have 2 periods. We need to graph 2 periods of this. And so notice what's always going to happen, right? The period is 2 here. Takes 2 units, 2 x units before things start repeating. At half of that period, 1, that's where our asymptote is, right? X is equal to 1 is one of our asymptotes. And then we just add another period, add 2 to that to get 3, and that's where our next asymptote is. Or we could subtract 1, period, 1 minus 2, -1 is another asymptote. So again, remember, for the asymptotes, you just find one asymptote and then keep adding or subtracting the period to get all the asymptotes, okay? So this is kind of the information we're going to graph. And then there's also one more piece that you should graph. And that is this point right here, the midpoint between the middle and the asymptote. Okay, this is usually at a quarter of the period. Okay, and this has to do with that pi over 4, that point when the x value is equal to the y value on the unit circle. We'll talk more about that in the next video, but for now, let's kind of look at this. So what we're going to do is we're going to start by looking at the asymptotes. Just like sine and cosine, we're dividing this into 4 parts within each period. Okay, asymptote, center, and other asymptote. That's half of those 4 parts, and then there's one more division at half the period. We have this point. This will always be a nice point between our quarter of the period, halfway between the middle of tangent and the asymptote. Okay, so period is pi. Sorry, the period is 2. So let's start at 0. Start right here. Oops. Start right here, and let's use a different color. Start right here. And then the asymptote is at positive 1. Let's count by 2s. Okay, let's say positive 1 is right here. And this is 2, and that's 3. All right, just to make it look a little nicer. Always include your scale. Sorry. Let's count by 2s. Or let's have 1 be over here, 2 boxes, then 2 be over here, 2 more boxes. And then for the y coordinates, we can just count normally. Again, the scale for the x and the y coordinates does not have to be the same. You can use a different scale as your x and your y coordinates. Just try to fit it to the graph. Okay, so we have this. Our asymptotes are at positive 1 and positive 3. So let's draw those in a different color. Asymptotes are at positive 1 and positive 3 and negative 1 and negative 3. But we only need a graph. We were only told to graph 2 periods. All right, so these asymptotes are going to help. And now the other point that we always need to graph the middle, graph the asymptotes. Let's list those actually. Graph the asymptotes. Graph the middle, whatever that turns out to mean. Kind of the 0, the center. And then halfway between, also plot the point halfway between the middle and the asymptote. Okay, and that has to do with tangent of pi over 4 equals 1. That's this point. Okay, now we're scaling this, but it defaults to being 1. And since this is a multiplication, a vertical stretch of 1/2, so like a compression, this point is no longer at 1, this point is now at 1/2. Just like on this graph, we can look at it right here. Point 1/2, comma 1/2 is on this graph. And similarly, negative 1/2, negative 1/2. And then all we do is fill in the shape. Like so. And then we just copy everything over, right? It's periodic. It does the same thing over again. Here's the new center. Here's that new point halfway between the asymptote and the other thing. The asymptote and the center, the middle. And then you do the same thing. Like so. And these are the 3 things you want to include in a graph. We'll talk more about that in the next video. But for starting, that's where we're going to be. Okay, Good luck, and let me know if you have any questions.